A lot of us don't understand how you're getting to them. Like that there's two subnets, and I don't know why I'm not getting it.
Okay.
I don't understand why you do it. To be honest.
To make more
Well-
IP addresses, right?
So you know how to
if
make.
we just had a classful, and again, this is a classful address, correct?
Right.
Yeah.
This is classless. Once we start breaking it up to give ourselves more IP addresses.
Yeah.
When you have a classful address with a classful subnet mask, how many IP addresses are available?
254.
Correct. Because you have your network ID and your broadcast ID.
Right. But now,
Okay.
how is there more than 254 over here now?
Because we've changed our subnet mask and we've opened up our ranges.
Because you're not using anymore only
Because now this is
255 or 0. You're using also the mid number. Like
I'm sorry?
you're not using anymore only 255 or 0. You're also using 240, like in this case, or 232. I don't know which are the other ones. Replacing out 255, 255, 255. That's 0.
Right.
Or have 255, 255. That's 0. That's 0. You have also 255, 255. Like 240 or 2 something else.
224,
Right.
192.
Okay. So you get more subnet mask because they're using also other.
Okay.
Because you're breaking up
Number
your IP addresses.
So you're getting more addresses in that you can have more subnet masks. You're not
Right.
getting more addresses within each subnet mask.
Right.
Okay, now I understand.
Does everybody understand that?
Yep, I agree.
Okay, and the whole reason why we do this is segregation,
Got it.
for security, for different reasons. Okay, so let's do this one more time.
To make, maybe on our network too, for SJVC, to make more addresses available each time we step on.
I'm sorry, say it again.
For like our network right here, to make more addresses available too as well. That's what we do. You guys do it.
It's more of a segregation
For
thing,
segregation, yeah.
because the addresses that we get out here, it's actually a class A address because it starts with 10, correct?
Mhm.
The subnet mask is a default class C subnet mask, correct?
Yeah.
So it's been subnetted or cidered, okay? So again, when you create your cider table, first thing you do is you lay out your binary, okay? And this will give you the IP addresses. Okay, and we know these are all the values for the bit positions, right?
Yeah.
Okay, because there's 8 positions. When we borrow a bit to subnet, we have to borrow from left to right. If we borrow 1 bit, the new subnet mask would be 128. Okay, that's that first bit value. If we borrow 2 bits, 92. 128 plus 60. Excuse me, plus 64 is 192, correct?
52.
We borrow 3 bits, 224, correct? 128 plus 64 plus 32,
40,
correct? 4 bits,
240,
48,
252, 254, 255.
okay? Because there's 128 addresses available, we know there's more than 128, correct? Simplest way to do it is raise this to a power.
Then you got
128 times 2 is 256, correct? So if we raise this to the power, it'd be 2. This is the number of subnets.
Then goes forward.
I'm all over it now. I totally get it. What I was getting confused on before was how you're getting the numbers across the top. Well, I see how you get the numbers across the top now. The numbers on the bottom mean nothing because that's what I understood that originally. I was just
Okay, so
wondering.
you just couldn't get the subnet mask.
Well, what I was interpreting was that you were saying that the number of bits that you're borrowing raised to the power is how you're getting the subnet mask, and that's where I was just like, what? I was confused, and then I'm seeing across the bottom what you're actually talking about.
Oh, with the power?
Right.
Oh, okay.
Exactly.
It's just a lot easier to do it with the powers than try to figure out, okay, what
Absolutely. I
128 times what is 256? 64 times what is 256? Because we know how many bits we borrowed, if we raise it to the power, it's gonna give us that number already. Make sense?
exactly.
Yeah, let him.
You know something I was gonna. All right, I understand. Maybe I need to touch up on my math, but the subnets right there, like I understand that you got 1 and 2, but the 3
2
through
times 2
8,
times 2. 2 times 2 is what?
4,
Times 2 is what?
80.
It's an
Times two
exponent.
is what?
It's not
Exponent.
times 2.
4 times 2 is 8 times 2 is
Yeah, okay.
16.
So it's 2 times
It's
the
X
top.
powers.
Oh, okay. It's
2 to the
everything.
4th.
I thought it was. All right,
No,
now
2 times
everything
2.
is
4
times
times
2.
2.
Okay, now that's
2
we're
times 2.
golden now. I can't touch on math.
No. Okay. That's why it's in the bottom. Power that-
See, I was thinking that it was raw. Why is he writing it that way? Because I thought, it should be, not.
We thought it was.
I thought it should have been.
You thought it was like that, yeah.
Oh,
Yes,
no, no,
sir.
no.
Yeah.
Yes, sir. That's
That's
my-
why he
This
wrote
is
it
the
with-
power now.
Okay, just see that.
I would've thought-
That actually made it all everything fit in.
People probably don't ever use 128 because there's too little benefit for all that.
Yeah.
Yeah. And he probably even 64.
Yeah, and you're not gonna use the last one, again, it's 255, you're not gonna use this one. There's only 2 addresses available. Well, you need a network ID, you need a broadcast ID, right? You won't see 252 much. Again, network ID, broadcast ID, that leaves you 2 addresses for 64 subnets.
3, 4, and 5 are really gonna be your own.
That's gonna be where you're gonna, 3, 4, 5, and 6 possibly.
So did you do another example where you actually the ranges of IP addresses that you're getting from taking from either what position?
Okay, so how many bits do you wanna borrow?
4. Let's do something
4
different.
bits.
So I think we did 4 before. Let's do something different.
Let's just do
How about we
3.
do 3 bits?
There you
Okay, so now our subnet mask is gonna change.
One.
We'll just write the subnet mask here. It's 255, 255, 255,
That 2.
224, correct?
Yeah.
So what else is it telling us?
We have 32 IP
32 addresses, correct?
So 0,
Zero's first,
32,
32 and 32 is
64,
64,
96,
96,
128,
28,
160,
160,
192,
192,
224.
224,
256.
and the last one would be, it would be 256, correct? But we already have 1, 2, 3, 4, 5, 6, 7, 8.
And that's our subnets within it.
That's our subnets that we have available. So it'd be 31, 63, 95, 127, 159, 191, through 223, and through 255.
So now real quick, you can't use the number at the far end of the range, correct?
What do you mean?
Like
Like
last
31,
number-
Right, yes,
for instance.
yeah,
This last number is our broadcast.
exactly. Okay.
Okay. So now we know, so if we're gonna use a default class C, let's go to 10. C. Now it'd be our network ID. So our network ID for, let's say we're gonna use the 5th subnet. What's the network ID?
128.
128. So our first address,
192.168.10.127 or 129, yeah.
the last node,
192.168.10.1 It's
158, 158.
Everybody says that.
Our broadcast.
159.
Yeah, 159.
Okay.
Understand that?
Uh-huh. So you basically get to choose whatever range that you want, right?
Pretty much. You just
As long as you use the network ID and the broadcast, anything else in between is you're done.
Right.
Okay. Cool.
They tried to
That makes so
explain
much
this on
more
last
sense.
sentence.
I'm Australia. I'm in Australia.
No, I have to focus.
Network
I
mask?
can't.
So again, a subnet mask, everybody has to have the same subnet mask for everybody to be able to communicate, correct?
Uh-huh.
When we separate ourselves by subnetting, as long as we have the same subnet mask, we're okay. But if we were to change this, like let's say if we use the 240, then we're in a different subnet, correct? That's securing. That's segregating ourselves. We're isolating ourselves from
Like keep the financial department away from record keeping.
finance,
Yeah.
HR, whoever it is that we want to segregate
We have their
to
own
keep security, they would have their own
sub.
network. Make sense?
Okay, that's segregation.
Yeah. They just.
Sorry?
Yeah.
To separate the IP address
Aha.
Gotcha now.
for DNS.
Yeah, like primary DNS, secondary DNS.
This is mainly going to be for your nodes and for printers that are going to be attached to the subnets. You wouldn't necessarily do it for DNS servers, DHCP servers, things like that. They're going to have a default or a classful address with a classful subnet mask. Okay, and all of this can be configured in your routers and switches. Okay. So when we talked about with VLANs, we can create VLANs with switches, correct? Just let the switch know what IP address, what subnet mask goes to which VLAN. Make sense? In your DHCP server, you're going to be able to set all this up in your server, but it's good to know this because if you, for some reason, let's say you work for a company and they say, you know what, we're going to be purchasing a new building. We need to figure out a floor plan. We need to figure out how we're going to do IP addresses. We have X amount of employees on floor 1, floor 2, floor 3, and so on. How are we going to get all these people IP addresses? Well, here's one of your solutions. Okay. Now, also keep in mind that with a Class C address, a default Class C, the third octet is part of the network address, correct? How many different networks can we create?
254.
254, correct?
Just be the last.
Okay. But then when we break it up like this, we can expand that even further.
Now you go with
Yes.
thousands.
So let's say for your company right there, if you're breaking it down
Mhm.
into subnets and stuff like that,
Right.
let's say the finance department, like he was saying, would be 1 through 30. The HR would be 33 through 62, that stuff, and so on and so on. Or would we switch the subnets for them, or would we keep it like that?
You could.
You can do whatever you want.
You can switch the
Okay,
subnets. And keep in mind also that you're going to have permissions and group policies in effect. Okay, so you'll have your finance group, you'll have HR group, and they'll have permissions to folders, to storage areas on the servers. That's also a way to help keep your network secure.